So yes, I'm Ines from BioMixing. Well, my pitch is probably the most stranger today because we optimize bioreactors. The first question is, what are bioreactors? They are the basic equipment to manufacture many pharma drugs, like vaccines or cancer treatments. But the face cream I'm just wearing, the yogurt I had this morning, or culture meat, they are all produced in bioreactors. So they are used in pharma, cosmetics, biotech food, traditional food, and many fermentation processes. It's a very large market. It has many needs, like they are very expensive or processing times, they can be very long. Many of us probably will remember COVID-19 vaccines that we different countries were fighting for getting them because well they were invented, they had to be produced in bioreactors, and it took some time. The product quality can be poor sometimes because this is a live culture, so they need to be grown with nutrients, with oxygen. So if you agitate them very intensively, you can damage them because they can suffer from shear stress. And if you don't agitate them enough, then you may have problems of homogeneity, or part of the culture may die. Energy consumption can be high when working at the industrial scale, and there are also many steps in the scaling process. What do we propose? We propose an innovative agitation and ideation system that can be used to retrofit our clients' bioreactor or fermenters, or we can offer a whole new bioreactor or fermenter with our agitation and ideation system inside. We can make simulations based on complex mathematical models and our knowledge of fluid mechanics that can reduce the process of scaling, because using some sort of artificial intelligence, we can create a digital twin so that we can predict how the culture is behaving in a large bioreactor based on how it behaves in a small one. Our better design of the agitation and ideation system using these simulations allow energy savings, and they can also lead to a higher quality product and reduce the processing time up to 50%. So at the end of the day, we can get for clients a saving in money and time. Out of all the components that the bioreactor has, we focus on the two that impact more on the efficiency of the bioreactor, which is the agitator and the ideator system. We have realized that they have hardly changed over the last 30 or 40 years, with the exception of single-use designs. This is probably because you need to be expert in fluid dynamics, in complex mathematical models, or in aerodynamics. So this reduces the number of experts, and probably they are all in Boeing or in Airbus. Here on the left, we can see a bioreactor of one of our clients, and on the right is the same bioreactor after we retrofitted it. You can see that the bubbles are much thinner and much more uniformly distributed inside the bioreactor. So we got for this client a 50% decrease in their processing time. These are some of our clients and what we achieve for them. And we are looking for collaborations for firms that are worried about sustainable manufacturing, or that worry about more efficient processes, or even feasible processes, because in some cases, like cultivated meat, for example, well, they are not more widely distributed due to problems in processes. And with this, I finish my presentation.
Thank you very much, Ines.
Thank you.
Again, a reminder to post your questions in the chat. And so I'll start with one for you. Why are there no other companies, would you say, doing exactly what you're doing?
Well, we think that it is because this is complex. Fluid mechanics is a very, very complex topics. You also, to design this type of agitation system, you need to include lots of parameters like temperature or pressure, or the culture growth curves. So you need to know complex mathematical models, also aerodynamics. So this this reduced really a lot the number of experts. Yeah, as I said before, probably they are all in the aeronautical industry, yeah,
Mhm.
in that sector. So yeah, in the aerospace sector. So yeah, I think that's why
Yes,
they are.
a few reasons. And
Yeah.
up to what volume of bioreactors can you retrofit?
We have no problem with the size. We are expert on fluid mechanics, and with these simulations, we can simulate any size. So size is not really a limit for us. We have designed some of them which were, well, tens of thousand liters. So yeah, no problem with
Okay,
that.
thank you, Ines.
Mhm.